Okay, I think we can start. Hello everyone. Today is the day of the ninth task, and this task is about containerization. Today is Thursday. Yeah, I try to find for you a lecturer who will describe you Docker, who will tell you everything about. But unfortunately, we couldn't find it, and seems like I will have to do it by myself. So today will be a bit scuffed, but I'll do my best. Okay, so unfortunately we don't have any video in English, and that's why I tried to find someone to create those videos for you, but I didn't find. So hopefully some of you already read all this stuff about Elastic Beanstalk, already read about Docker. If not, it's not very critical, because I will tell you about Docker. Actually, this task is not very hard. It's pretty simple. It can be done just like with one file and a few clicks. But the idea of my today lecture is to try tell you why do we need Docker, why it's cool, and why people using it everywhere right now. And to do this, I will use our Russian language materials. Yeah, that's why this stuff will be very scuffed. So I don't even have presentations, so I will just follow the stuff we have here, and I will talk to you about it. So yeah, let me check that everything works. Yes, you can see this. It's cool. It's cool. Okay. Let me open chat. So let's go. I will do my best to tell you everything about Docker. I will not go too deep because I don't have really deep knowledge. I work with Docker a lot, and I pretty understand why we need this one, and I will try to tell you the stuff about it. So first of all, why do we need the Docker? Yeah. Usually when we work, we use different services. Yeah. So for example, you're a Java developer, you are a backend developer, and you have your own machine, and you're running only Java code all the time. You don't run anything else. Yeah. And for example, you came to another company and you have to check your backend on front end. Yeah, so people from your company gave you a code in JavaScript with React, for example, and etc. etc. So you as a developer, you will have to adjust your system, so make it to work. So you will have to create the new dependencies. You have to install, for example, Node.js. You have to work with environment variables, etc., etc. You have to create all the ecosystem inside your own machine to let this work. Yeah. Also, if it has some, for example, some additional services. So, for example, some Node.js server already running for this application. So it will be a bit complicated for you, and you will have to do some preparations to make it work. And with Docker, you can just run Docker, pull image, build it, and run. You don't have to adjust anything inside your own system. So the Docker will do it inside its own container. So this is the biggest benefit of the Docker. You don't have to use different systems. You don't have to use, you don't have to add anything that you don't need in your work. Yeah. So you develop your backend, and you just run your front-end application inside the Docker container, and it just runs here and works, and you can open it up. And that's, I think, one of the biggest, I don't know, upside, yeah, not downside, yeah, upside, I think, of the Docker, because you just can run anything you want and not adjust your system. Yeah, also Docker usually very much is used inside CI staging environments. Right, if you worked with CI, CD, some, I don't know, maybe TeamCity stuff, usually all the builds inside these applications, they they create Docker containers, separate Docker containers inside itself, and just you can switch the builds very fast because you don't have to rebuild anything. You just have completely complete image of the application you just created. Yeah. And the same is for production. Yeah, you don't have to do anything. You just pull in images and they are working. It doesn't matter where you're running it. It's just you don't have to check operational system. So for example, I don't know, maybe code was written for Linux and you're using Windows, and you will have to investigate how to run this project on your Windows system, and it will take much time, and inside the Docker it will use itself its own system. So yeah, that's actually what about why we want to use Docker. Yeah, so how it works, actually it's pretty simple. So we have our own operation system, we have Docker, and Docker just creates containers inside small containers inside your own operation system, but those containers actually have its own environment. They have, you decide what, for example, how many memory you want this container to use, how many process powers you want this container to use, and you just create a small independent blocks inside your own system which can work separately from your own system. So it's almost it's really looks like virtual machines, but virtual machines inside virtual machines we usually create operating systems by ourselves. Yeah, so they are they will take much more resources because you have to, so for example, trans 3 different applications in 3 different operation systems. You have to create 3 virtual machines, and they will take very much a big bunch of resources. And inside Docker it's more simple because we use only one operating system. Yeah, that's what about it. And yeah, my video is dead. Let me. Nice. Just don't tell me that our videos are dead. Let me check. Yes, stream is online. It seems like video portal just died. Really hope not too much. I love this stuff. Yep. So this video works, and this one just don't want to work. Let me try to close this one and open our video again. An error occurred. Okay. It's awful. 504. Yep. Seems like our video portal just died and I can't use my videos. It's cool. Yeah, I can't open video portal right now. Can anyone try to open video portal, try to open Russian materials, and is it work for you? Maybe it's just my problem. Maybe it's just my... Yep. So seems like it's not working. Yeah. It's so funny. Yeah. Okay. Okay, let me check. Yeah, it just died. Okay. So about Docker ecosystem. So what I started to talk about, yeah, so we create small containers inside our own system, and it helps us to build applications and build them separately from our system. So I think because we still have some stuff, maybe it will come up. I will show you just how it works. So how actually this stuff works. When we work with Docker, we have an application. Yeah. So for example, for my example, I have I don't know, maybe oh yeah, good example is will be our homework. Let me open it. Yeah, I will also check. Maybe this one will come back to us later on. Maybe not. And let me check our service template repository. Yep. Today lecture is very scuffed. Okay, so here, what do we have? Yeah, we have a small API. We have Nest.js server. Yeah, and to run this one, I know that some of you guys are Java developers. Some of you don't run JS, so it will be a really cool example for you because from our side, you just don't have to do anything. Yeah, you don't have to create Node.js or something else. You don't have to install this one because what we will do, the main task for this week is to create Docker file and to let Docker build the application for you and to create it inside its own container. Yep, and for this case, you will just have to set up Docker file, and you don't have to actually create install node on your PC. You just need to run Docker stuff. Docker will pull Node.js from its own databases. He will run the application. He will build the application for you, and you don't have to change anything. Let me check Docker. Yeah. So about infrastructure, I have some images, I believe, my working images. So I will just show you basic infrastructure. We'll tell you some basic stuff about it. Maybe our video will come back somehow in a few minutes. But yeah, so what do we have? We have actually three main stuff. Yeah, we have images, we have volumes, and we have containers. So images is actually the already built applications you have. So in my case, for example, for my work, we have, for example, DynamoDB database, yeah, and we have Vault where we store environment keys. We have Redis as cache. And in my case, for example, on my local system, if we check terminal, I do believe I have nothing about Redis, and I don't have anything about DynamoDB in my system installed. So Redis, yeah, not found. So, but I still can use, and I still can run Redis server. I still can run DynamoDB locally, and I don't have to install any infrastructure of DynamoDB, any CLI tools, anything. I just, we just have an image where inside we have DynamoDB. As you can see, this image weighs like 500 megabytes. So inside this image, we have all files, all libraries which DynamoDB needs to run. And in my case, I don't have to install it locally. I just can like start my image, run a new container. So when I try and maybe run, it won't work as expected, but I can run this stuff. So as you can see, we just initialize on port 8000. He is inside, do its stuff, and as you can see, I have container which is running on port 8000. So I do believe I can connect to this one on port 8000. Let me check. Yeah, I can't. What will be the better solution for this one? because I started this guy. Delete. Yep, I'm removing this one. Let me check. Can I run image actions? View packages, CVs, run. Optional settings. Postport 8000. Volumes container. Yeah, I don't have anything. Give me a second. Let me run it for myself. I need this guy here. Because we don't use Docker files, we use scripts, and it's a bit more advanced stuff. That's why it doesn't work as I expect. Give me a second, I will run this guy. I think we can run Vault. Okay, so right now I'm trying to run one of my images. Because we're using script, not Docker files, we don't have any configurations inside here, so I have to run my script. And give me 1 minute to my image. Yeah, as you can see, Vault became in use. You can see it here. So it's showing that right now Vault is already in use. We can go to containers. We can see it here. We can go to this port. And as you can see, my Vault application is running. So build of this application took for me like 30 seconds, I believe. And I don't need anything like infrastructure of Vault, how it works, or I just don't need anything. I just run my image and it mounted and it works. That's how it goes. Also, if we create image and we run it inside a container, all the changes, they will stay inside this container. So when we remove, can just remove, delete my container, all the changes will be removed. And for these cases, Docker infrastructure has this stuff. It has volumes. As you can see, 2 of them right now in use. So it's a small containers for memory, for local memory, not operational, but local memory, where actually my operating system just gives to my Docker a piece of my local space where Docker can store the data. So because I use volumes inside my containers, I think we don't have to use them in our task, but you just have to know about this. Yeah. So because we use volumes, we can change data inside the containers. So if I change any data, it will use my volumes to write down the data, to store this one and update them. And next time I will pull up my image, it will connect to my volume and use the data. So Docker is, you can think about it like a small, very, very small version of your own PC, and with very restricted resources, but it just works in a small space and use not all your available space, for example, all your resource from your own PC. So you can create like many containers. So usually I run, for example, 3 different containers. You can I had one project before where it was a front-end project and we had like 10 or 15 different services, microservices, and they all were written in different languages because different teams worked on it. And I just ran like 10 or 15 different containers just to let my front-end application work. I just had no idea what was inside this service, and I didn't want to know what was inside the service. I just wanted them to work, to run, to let my application work. And that's how Docker really helps us. Let us check, and yep, this guy is alive. So let's go back and check. Maybe I missed something. Yeah, and as I told, our image has its own layers. So every every time when we run Docker, we choose what system we want our Docker container to use. So I can't tell you more about, but actually, yeah, we have like different containers. So we have small containers, for example, Ubuntu, running on Ubuntu, all of them running on Ubuntu. And here in an example, let me check. So here, yeah, we can see that Docker run Ubuntu test, Ubuntu bash. So our Russian language lecturer, he is trying to run just a small container with the Ubuntu environment inside it. And he want to run bash terminal inside it. So when we run this one, so we ran uname -a, and you can see that we are inside the Docker. So as you can see, this bash command, it not just created a Docker container, it created a small Docker container and started bash inside it immediately. So as you can see right now on the screen, our lecturer, he is just creating a new file. So he is checking right now containers. So you can see Ubuntu image. It has bash, about a minute ago it was created, and name of this container. So here he created image, and right now what he have done again, he started Ubuntu test. He started by the name. He attached container here 38. You can use ID to attach it inside it, and as you can see here inside we see that our hello world is exists. So the file he created exists right now because he didn't stop the container. He just ran it inside terminal. If he remove this container, I believe he won't. Yeah. So right now he is removing this container, and after he removed this one, container will run without any more files. Yeah, that's what I told you about volumes. Yeah, and he is talking about the stuff that usually people run containers, they forgot about the volumes and they are losing their data because they do not using any volumes for their containers. Yeah, when you remove container, you remove all the data. Let me go further. Yeah, and as I told you before, yeah, we have container. We can we have inside Docker area our own file system, and we can give a small volume for it to store memory inside this one. So yeah, I even showed it a bit. And here, as you can see, script was changed a bit. So right now it has flag -v, and Ubuntu TMP /TMP. Yeah, so here he creates a volume for his own Docker volume. You can inspect them here. So that's what I told you before. So you have to create volumes to store the data somewhere. So when you remove your Docker container, the data will not be removed anywhere. And here he will just run again the same stuff. He will create a new file with the hello world inside it, and he will remove the Docker container, but because he created with volume, when he restart the container, the files will be here. So yeah, he is running container again with the same volume. So here he just so what he is doing right now, he creates a new container, completely new container, but he uses the volume which was created before. So he created a small system, and he used volume, and you can see that the files will be inside the volume. That's also pretty interesting stuff, because in our example, yeah, so I have volumes which are in use by my vault, for example, and I have image of my vault. And if I will create a new image of the vault, I will create or I don't know, something new, I will just remove this image and I will create a new image. Because I use volumes, I can just tell my new container to use this volume, and he will just, okay, why not, he will use the volume. So that's also pretty interesting stuff, because you can get rid of containers all the time. That's actually what I'm doing every time. Yeah, so when I stop into work, when my PC just, I don't know, maybe lagging sometimes, I just can remove my container and restart it again, and I'm pretty sure that all my data will be inside, because I'm using volumes. Yeah, that's how this stuff with volumes work. Let's go back. I think, do you even understand what I'm telling you guys? Maybe you need, you have some questions. We have not much people. I'm trying to tell about the stuff I don't know very good, but I do my best. Maybe something is not clear. Maybe I will try to explain it in simple words. But actually, it's just small system inside your system. A really small system. Chat is dead. Hopefully you understand everything. If you have any questions, feel free to ask, because yeah, it can be a bit not too structured from my side. Also, our video died, so I had to improvise. Okay, the next step is so as you can see, our lecturer, he took Ubuntu, yeah, and he just printed Ubuntu and took it. So Docker has its own hub, it's called Docker Hub, where you can find the images of the most popular stuff that you need for work. Yeah, so here, so actually you inside the Docker Hub you have already prepared containers with the environment you need, with very popular environment. So for example, here, as you can see, from node 10, yeah, it means that our Docker will go to Docker Hub. He will take node with version 10 container. He will just take it, pulls inside it, so is the system inside, so the small system inside will can understand Node.js code, yeah. So then we can, for example, create our application folder. We create our package.json from our project, and we run npm install inside this Docker. So he knows how npm works. He knows how to run node projects. So you don't have to install Node on your own machine. So Docker will do it for you. He will run it inside its own container, and you just don't have to install new packages to your own system and I don't know, use your space, and it's pretty cool. And when you want to remove this one, you'll just click one button, and you don't have to clear your system from Node, like finding where it just pushed its tentacles inside your system. Yeah, and it's about Docker files. Yeah. Okay, and here, so about a small talks about how Docker file works. It's actually the part of your homework is to create Docker file, to create Docker container. So as I told before, it's just a base image which you will use inside your system. Yeah, so you just pull node 12. Node 12 Alpine is optimized node 12, so it's just way, like, I don't know, maybe 10 times less than node 12. So from command gives us opportunity to take our base image And on top of it, we will copy our files from our directory inside the container. So that's how copy works. Usually people use copy because add the command, add files from URLs, it's pretty cool, but also it will impact our archives, and sometimes you don't need this one. So usually inside Docker files, people using copy because it's just copy your files directly to your Docker. Let me open, I don't know, maybe I pushed cart. Give me a second. Not sure that I pushed this stuff. I can check. Yeah, I tried to test stuff, but I decided not. So yeah, now let me just open anything. Yeah, so we have, for example, product service, and inside Docker file, we will just add copy, and with this copy, we want to copy all the files. And here, give me a second. So we can copy, we just show from where to where we want to copy our files. Then what else commands? From, copy, add, run. What run does? Run command, it will just run script inside your container. So actually just, it's like you open terminal and run something like npm run, and that's what the run command will do. It will just, so you, the steps is next, you create from, you push, you pull base image from Docker Hub, like Node, then you copy your files, and then you run npm install, for example, to install all the packages inside your Docker container. Entry point or CMD is also used to run a container. So it's a command. When your container, he made everything, he is still not working. So he's like, it's just the files somewhere inside. Yeah, so you're like, okay, it's exists. But we want to run something inside. So for example, here we can use node index.js. It will means that our container will run index.js file with node, and the process will start. So here, that's how we can run our projects. Give me a second, because almost, yeah, Docker registry is how the Docker works. So yeah, we just, as a developer, we can have, we can hide our public registry is actually Docker Hub, so it's public containers. We can have our private containers somewhere else where we can store our projects. So we don't want them to be public. And I think that's almost it. Yeah, Docker components. Registry is where we store our files, images, containers, and Docker build, Docker pull, Docker run. And that's it from this stuff. And what I wanted to show you also, Dockerizing a simple application. Yeah, so it's more close to your homework. So your homework actually is to Dockerize the application which we provide you, a REST card API. It's already working, it has to work, and you just have to create an image with this stuff and run it. And now, for people who came here, yeah, making Docker file. So you, in your homework, if I remember it right, give me a second. Why he always trying to open desktop 2? I don't know. He's just like very worried. Where is, oh yeah, I got it. So as you can see in your task, let me open this one. You have to create Docker ignore. You will have to create by yourself. Yeah, it's optional, so you have to optimize your Docker build. You have to read by yourself. Maybe we'll find some. So you need to create a Docker file from previous subtask. Previous subtask was, yeah, create Docker file that will build a Docker image to run the card service. And here, as you can see, actually this one, is not updated, it's not optimized build, and that's the point of your homework, to create more optimized. But actually, if you just create Docker file with these commands, it will work. So your Docker will create the application, run it, and yeah, your homework is almost done. What's left is optimize the stuff. So and also push it to Elastic Beanstalk. Yeah. So as you can see, what we are doing here, so we pull Node.js version 12.16. I don't know, try 12.16. If it will not work, try more powerful Node. But I think our task repository was not updated for a pretty long time, and I believe 12 will be a pretty good version of Node, and it will work on it, because I do believe we did not update much stuff. Updated some packages versions 2 weeks ago. Yeah. So try to run on 12, like here, maybe you can use 16 node, it will run 2 again also. So we create our Docker container with node 12. We create work directory named app inside it. Then we use copy, I don't remember how simple the name of the symbol, // so we create all the files in our app. Then we run npm install npm run build, so we install all the Node.js dependencies. We run our builds to create this directory with builded files. Then we use Node, we expose our Docker to port 4000, and we use entry point node is main.js. So that's the whole actually it's like half of your homework here. Yep. Next step is Elastic Beanstalk. Elastic Beanstalk actually is a service for, I think some of you already read about it. So it's a service which from AWS, which gives you an opportunity to to create your service in cloud. Yeah, you can create your solid servers. We already used Lambdas, and it's more about microservices, but sometimes we need some solid solutions. We need to create a solid server somewhere, and for this case usually we use Elastic Beanstalk. So that's the main feature of this guy, to create your server somewhere in the cloud. So as you can see, Elastic Beanstalk from scratch, he ran different code. He ran Java, he ran Node.js, Python, and also it can use Docker. So it's actually two ways. You can use your Node.js code, put it inside your Elastic Beanstalk, build it inside here, and expose it inside here. But I think more common solution, which right now everyone uses, is Docker. When you create builds, create Docker containers, and just set this container inside Elastic Beanstalk, and he's like, oh, all right, I'm just running this stuff, and it works better, because you don't have to manage operation system of your Elastic Beanstalk. Yeah, you don't have to work with how it should work. We just set it with Docker and it's okay. So as you can see, yeah, if you are using Docker, what you have to think about is application and the data you're using. If you are not using Docker, you have to also think about how it will run time, and that's how Elastic Beanstalk works. So you don't have to think about virtual machines, about services, storage, networking, about scalability and everything else. So that's how Yebe works. He just do very much stuff instead of you. You just have to think about your application, how it works, how it performs, and that's it. Yeah, Elastic Beanstalk is pretty simple stuff. He's just running somewhere in cloud your server. for you. The next step, deploy and delete with AWS Elastic Beanstalk. As you can see, you have to use YB CLI. You also, I think you can find a solution how to deploy your application with the AWS itself. So just go inside the console and put your Docker image here, but CLI will be a better solution for you. So just install this one. Give me a second. Yeah, install YB CLI, set up scripts run, and here, as we can see, give me a second. Yeah, we have after you install Elastic Beanstalk, you can use help button to see what stuff it can do. Here we have many options. Give me a second. So yeah, about the options. Yeah, now we have YB init. It means that we can initialize our Elastic Beanstalk. We can create something inside it, deploy something here. We can terminate our Elastic Beanstalk instances. We can set environment variables of this instance, config this one, and also we can list our instances. So here, let's go further. So first command usually is init. So inside the Elastic Beanstalk, we have two steps inside, two tabs. It's like environments and applications. So our application will have to go at the application tab later on. So here, as we can see, our lecturer, he is trying to init, and he uses help to check what he can use. So he uses verbose for better output. He uses, I think, profile, because he also have different profiles in his AWS. So yeah, he is using like region US West 1. He is using his personal account, and also when you trying to do something with Elastic Beanstalk, he also ask you, do you want to continue with code commit? Code commit is some kind of version system, version check system like GitHub, yeah, but inside AWS. And usually you don't want to use this one because, as we know, nothing is free, yeah, from AWS. So you don't want to use code commit usually, because he will just commit your code, store some copies somewhere for you. Yeah, it's pretty cool, but we usually use GitHub and store our code here, so we don't use code commit. And also you can set up SSH for your instances, but we don't need this one. We are just learning. So here are some magic with the code, and here's the Docker file. And as I told you before, yeah, almost it looks almost like the Docker file from the previous slides, and with the only difference, as you can see, we have copy run twice. How this stuff works, and it's pretty interesting because you will have to work with optimizations. How this one works when Docker is also pretty I don't know how to tell. He's very smart. Yeah, he is very smart, and he can not run some lines of the code because if they are not changed. So how it works? So here, as you can see, we copy package JSON and then run npm install, and after that we copy everything else and run build. So Docker file, Docker, when he sees Docker file, when you run it first time, he'll copy package.json. Package.json is the file where the project dependencies are stored, where we set up our libraries and everything we need to our code work. And if I remember, we have a pretty big stuff here. Give me a second. Where is our card service template repository. Second, and yeah, as you can see here, inside package.json, what libraries do we have? We have pretty much dependencies. Yes, we have dependencies for our Nest.js application, so our framework to run our server. We have Jest, Prettier, some testing libraries. We also have ESLint for code styling. Also, we have TypeScript stuff here. So pretty much libraries. It's Nest.js will take some space. Also, we have like Passport RxJS will really take a bunch of time to download. So when we we also can just copy ... and run npm run build, run npm install, and run npm run build. So when we change something inside our code, when we try to build Docker file, he will all the time he will run npm install. So it will take from him like maybe 2-3 minutes to get all the data. It depends on your internet, of course, to get all the data from the web, to install all the dependencies. But if you just copy package.json separately at the start, so how it will work, when you run first time Docker file, he will like, okay, I have package.json, first time, he will run npm install, then he copy everything else and run build. And if you made some changes and you didn't change anything inside package.json, he will like, okay, I copied this, and he will see like, I don't have to copy this one because it didn't change. And he also will skip run npm install because their works like they're a bit connected. Yeah. So what we done, if we skip copy, we skip run, we skip everything after the copy for the next copy. It was done for especially for optimizations of building time, so we don't have to install dependencies all the time. And here, if I remember right, give me a second. Don't tell me that you died again. We need you. Yeah, as you can see, yeah, so we created Docker file. So what are you doing? So yeah, he right now on the screen, he just ran our project, just checks that it works. So he just ran the application. Give me a second. Did he build this one? Give me a second. Docker file. Give me a second. He used start dev here. He just started the server just to check that this one works. And when we done that, we start to create our Elastic Beanstalk environment to set up this one. This data is a bit outdated. I think this video was recorded like 2 years ago, and as I told before, I didn't find some lectures to tell you some stuff about how it works right now. But as you can see, for Docker stuff, we have 2 different versions. One is maybe right now we have different versions. Just check if you have 2.16, you can use this one. So try to use the latest version and the stable version of the Docker inside your environment. And what do we have now? So after Elastic Beanstalk init, it will some configuration file will be created inside your application. So as you can see here Elastic Beanstalk, here we have a config, and this folder you want to add to your git ignore, because you don't want this one to expose somewhere. Just why you have to show somewhere your Elastic Beanstalk configurations. Also, I think he will just, yeah, he initialize it again. Before we remove all the stuff we already have inside here, just to be sure that everything is clear for us. Yeah, he also removed dist file with the already built stuff. And the first step is initialize application. Yeah, so he initialized it without the name, so we have to add the name here. So he create the name. Also, it scanned your file system and it found Docker file. And he also just BCLI, he's asking you like, hey, you're using Docker, is this correct? We're like, yeah, we are correct. And he gives you three options what you want to use. And the multi-container we don't need because we will use only one container, I believe. And also, I think you have to use Linux too right now because it's just better. I think, yeah, because it was 2021 and our lecture used Linux first. You can use, if you have, I really think that it's not even inside right now Elastic Beanstalk, but if you have Linux first, you can use this one. Maybe you can run on the second version, just try to make it work. As I told before, we don't have to use code commit or SSH. And after the init, when we go to our application tab, we will see our application. Yeah, it's cart API, like you named, but it's nothing inside. It doesn't have any environment. It doesn't have any code. You just created a clear application. You don't have anything inside it. Yeah, it's about, he is right now talking about Elastic Beanstalk configuration file. He will also, when you run initialize, it will add this one to git ignore. Just don't forget to not expose this stuff. So we initialized our application, and after we've done it, we want to create something inside it. Yeah, so we want to add our application here. And here, as you can see, he's talking about the flags, load balancer type, classic application network, and as single environment will use a single instance with no load balancer. What is load balancer? It's like the service which is provided by AWS. It gives you he will check how many requests comes to your Elastic Beanstalk application, and he will balance it. And if you create it like if it is too many requests, he will not let your application to those for some time. Yeah, but it will be too much. He will just fail to balance this stuff. And also he will help you if you have multiple instances. He will help you to spread I forgot the word to spread all the requests between your instances. And single means that you don't need a load balancer. You will just single instance and let's go. Yeah. And I really think you don't have to use load balancer because, as I told you before, nothing is free on AWS, and load balancers are, yeah, they are pretty different. They have their own setups, but we will not use, I believe, this one because we will just run a small application. We don't have to balance between different instances of our application. Okay, let me skip it, this one a bit. because yeah. Yeah, as I told you before, we will use just a single prefix because we don't need to create load balancer for us. Words, many words. Load balancers. Let's go. Yeah. Uh, oh, yeah, as you can see, so here on this slide, we can see that to create our application, we need to Elastic Beanstalk we create like environment. Yeah, so we create development environment. So here we store we create a name for this environment, and inside the environment we can create our own environment variables to let this stuff work. So on the screen, this one, eb create minus minus single. He also didn't press anything name. We want so we create namings for our environments. We don't need spot fleet requests. I don't even know what stuff is this. It's like some type of request. You can read it by yourself, I believe, but we don't need this one. And as you can see, he also eBay created application versions inside our Elastic Beanstalk folder. So when we pull this create, what is going on? He is uploading everything inside our directory. He used Dockerfile for this stuff. So he archived everything inside .zip file and pull it to S3, because Amazon always use S3 as the storage for files. Yeah, so he will push it to S3. Then he will use this S3 container to create your application. Also, after we made the create, as you can see, our application tab, it right now is a bit different because we have pending health. It means that right now Elastic Beanstalk is doing its job. He creates your application. He creates Docker. He builds your application. He creates Docker container. Then he builds the application, and he pulls it inside your Elastic Beanstalk service. And also you can see you already have URL, and this URL is actually the URL for your cloud application, which you have to use inside your front-end application. Yeah, so he creates all the infrastructure for Elastic Beanstalk right now. So we can go inside our develop. Yeah, he is right now creating. Now let's skip this stuff. Yeah, so our environment was created. Also, we have, if you have seen, yeah, we have developed an environment right now, environment health. Here inside the environment, as you can see, when we created something, we created develop environment, and here inside you can see logs. Also, it has like it told us that we're using Docker to post our application in the cloud. Also here you can manage your environment variables, you can read logs here and everything else. Yes, here also he's shown that right here you can see application versions, which right now, for example, he have like few different versions, and the latest one is deployed to your develop environment. And here, right here in this application tab, you can, I believe you can choose, like, for example, if your version doesn't work and it's inside the production, you can just choose any other version you already created and redeploy, for example, previous version which was stable and which was working. So AWS, he's just stored for you all the versions of your application. Also, I don't remember how much time it's stored. I think he will store it like for 3 months or something like that. I think you can configure this stuff, because you don't want to store all your versions, because you use S3 and store your application versions, and you will have to pay for this stored application versions. So yeah, be sure that when you will remove the stuff, remove all the previous versions of your application, just to be sure that nothing left and you don't have to pay for this stuff. So here's right now showing go to environment is actually the link to the web, HTTP link, as you can see, not secure. And here we already have our application and it's running. You will have to add this link to your front end part. Yep, and when you place this one, yeah, he is right now showing it. It will be HTTP. I do think you have to do some stuff to create it HTTPS. It's not like Lambda. Also you can, I think you can create HTTPS if you will add your Elastic Beanstalk. It will work with CloudFront, I think. Yeah, CloudFront. So you can add your Elastic Beanstalk as a source for your CloudFront, and it will give you HTTPS. But we don't need it right now. We don't need it in scope of this case. Here inside the configuration, you can see what you are using, how looks your Elastic Beanstalk container, yeah, inside AWS, what it uses. And here you can see environment properties. It's actually environment variables for your service. I think people who worked with backend and front end will know that we have sometimes like tokens, like application tokens, application keys, some data we don't want to expose in our code. We usually store them inside environment variables, .env files. So here you can see configuration tab is actually your .env file, .env file for your application. So here you will have to place all your environment variables so to let your application work. I don't think we have environment variables in our homework, but just to let you know, you will have to make it here. Yeah, so node env, it's just, yeah, database host, database users, all the stuff you used in environment variables. I think we use them in product service, yeah, like this one. So if you need them inside, you will need them inside you will need this one in task 10, I think, because task 10 is about moving your microservices to solid server. So I think you will have to use this environment variables, because you will have to place your database stuff inside environment variables of your Elastic Beanstalk. I think task 10 is about Elastic Beanstalk. I'm pretty sure. Let me check this guy. Backend for front end. Yeah, it is our last task. Yeah, task. Let me check this one. Yeah, you will have to create BFF service at the same level as product and import. The backend project structure should look like this. So you will have to create, for JS, you will have to create an SJS application, but for other languages, you can use any framework you want. So the main idea of this one is, as a final our solution, you just have to move all the stuff you made with your lambdas. You will have to create a solid server, small solid server, and you have to deploy this one to Elastic Beanstalk. I think we will change. It tells us that we need to use Node.js, but I know that some of you used the other languages, so yeah, platform should be Node.js. We can change it right now. Give me a second. While we are here, why not? Now we can remove this guy. Yep. We can just remove this one. Can I commit directly? I can only propose. So later on this will be changed, I believe. Yeah. Let me create pull request. So we can remove this. So yeah, inside the Elastic Beanstalk you will have to use all these environment variables later on, and let's see what else we can find here, what is pretty interesting for us. We can see, yeah, or create multiple instances here right now. So here we can check load balancing we don't use, auto scaling. So we, here you can see all the stuff which Elastic Beanstalk have inside. So we told about it. It's like multi instances, it's load balancing, it's like multiple instances here. You can run them here also. You can also change the settings of your stuff. And give me a second, I skip this one. And right now, as you can see, we can go to after all the done, everything is done, we can go to our endpoints and get our data for our application. Yeah, here as you can see, as I told, inside Amazon S3, Elastic Beanstalk, AWS is right here. You can see that here AWS stores the data which he uses for Elastic Beanstalk. And as I told you before, you will have to wipe this one out when you finish the course. Just do not pay for this stuff. And actually, that's it. It's pretty simple stuff. So I showed you like almost everything you need to do your homework, and the additional tasks will be to optimize your Docker file. Yeah, as I told you before, you will have to just try to read how you can optimize this one. I told you already about images. Yeah, so for example, Node 12, and we have Node 12 dash I right now don't remember the word Alpine, yeah, which just, if I remember right, Node.js weighs like 900 megabytes, and the Alpine version weighs like 90 megabytes, I believe. So yeah, try to find your way to optimize this, your build, so your containers, and that's all what's left for you, actually. Just optimize the stuff, because I already showed you how to create your Docker file, what you need to put inside this Docker file, and what commands you need to run your Docker stuff inside Elastic Beanstalk. And I really hope that I was useful, because as I told you before, guys, I'm not a master in Docker. Actually, what I done, I just was watching all these videos, just you could on Russian, but we all know, I know some more students can read Russian, but I had to create some small video. I really think we don't pull this one inside our right here, because it's scuffed. It worked not as expected, and I think for next course we'll finally find someone who will tell us more about Docker, and we'll have more experience in it. So it's running scopes, guys. We evolve from course to course, so I believe we will evolve to the next one, and I really hope that that was useful for you. Do you have any questions? Just not much people here. Just if you have any questions, just ask them. I will do my best to answer them. Maybe something was not clear for you. Maybe we can come back to some points, and I will tell about them again as I understand them. So my main idea was just to go through the videos again and to give you the most valuable information you need to know about Docker. Just I think the main idea is that he is not too hard to understand. It's small containers inside your operational system, and you don't have to do some work which you usually do when you try to run something in different language. So for example, my wife, she's right now learning C#, and to run C# project on Windows, it was like, it took us 3 days to run the application. Yeah, just to install everything, to make it work, to install dependencies. It took 3 days. And Docker, for example, he can run all the stuff inside the container, inside the separate system, and it will take like 2 minutes, and you don't have to worry about the system you have. You don't have to worry about dependencies. It will just work. So I think I think the people who don't run Node.js, who don't have Node.js on their systems, will feel the most benefits of this task, because they just don't have to do anything with this project. They just have to, okay, I create Docker file and I just run EB, and the Docker will build this one. I don't have to run all the Node stuff. I don't have to install this one, and it's pretty good. That's all from me. And as I said, do you have any questions? I'll do my best to answer that. Seems like not. If you have no questions, just or maybe you will have them later, just feel free to ask them in Discord, because in Discord we have people who know Docker better than I am, and they will be glad to answer, to help you. And yeah, I think we will see you next week. I already next week will be very fast, because actually it's nothing to talk about, not much to talk about. Yeah, we just have to move all the stuff we already done to Elastic Beanstalk. We told about it right now, and I really think that you can run it even with Docker, because here, as you can see, we'll remove this Node.js platform, so I think you just can use Docker here. Yeah, well, maybe the working core Nest.js should be in the, yeah, we will run through this guy, so not to make you create Nest.js applications for BFF service, because I think you don't, some people or some of you will have no idea how to create Nest.js service, especially the ones who not work with JS. Okay, thank you very much for your attention. Hopefully it was helpful, and we'll see you next week. I already read this one. I see issues in our task, and I will address them right now, so people will change some points, especially about JS, because we all know that we can use any language here. And try to use your containerization skills and knowledge I gave to you. Thank you very much, guys, and see you next week. Have a good